Last time, we turned words into numbers, text vectorization to map words to integers, and an embedding to give each word a learned vector of meaning. Lovely. But a vector by itself doesn't do anything. So today we put it to work on a real job, read a movie review, decide if it's positive or negative. This is the build and evaluate stage of our pipeline, except this time we run the whole NLP lab on real data, and at the end we type our own sentences and watch the model judge them. Here's the thread from last episode. We made word vectors. Today we use those vectors to make a decision. Thumbs up or thumbs down. Same machinery, real payoff. The dataset is the famous IMDb set, 50,000 movie reviews written by actual humans, each one labeled positive or negative, 25,000 for training, 25,000 held back for testing. No toy data, this is the real thing. First job, text isn't math, so we reuse text vectorization, exactly the layer from last time. We adapt it to the training text, it builds a vocabulary, and from then on every review becomes a row of integers. This movie was great becomes maybe 11, 18, 14 or 102, 0, 0, padded to a fixed length. Then the embedding layer, every one of those integers gets looked up and replaced by a learned vector, its meaning. So a review stops being a list of word IDs and becomes a little stack of meaning vectors, one row per word. Now the clever, almost suspiciously simple part, global average pooling 1D, we take that stack of word vectors and just average them, all of them, into one single vector for the whole review. Think of it as a bag of meaning. We throw the words in a bag, shake it, and read the average flavor. That one review vector flows into a dense layer, then a final neuron with a sigmoid. Sigmoid squashes everything to a number between 0 and 1, and we read that as the probability the review is positive. 0.96, almost certainly positive. 0.04, harshly negative. We train, and then the honest part, we evaluate on the 25,000 reviews the model has never seen. That's the only number that counts. Ours lands around 87%. For a model this simple, that's a genuinely solid baseline. But here's the catch, and it sets up everything next. We average the words. Averaging is order blind. To this model, not good and good not look almost the same. The bag has the same words in it. It can't read left to right, and reading in order is exactly what we fix next time with networks that have memory, RNNs. Let's read the code. One file, 2 pages. Page 1, load the data and build the pipeline. Page 2, build the model, train it, score it, and predict on our own sentences. Watch the gold box walk each section. Up top, imports and a couple of constants. Vocabulary size, sequence length, batch size. Then we load IMDb straight off disk with text dataset from directory. It reads folders named pose and neg, hands us a tf.data dataset of text and labels, batched, and we grab the train, validation and test splits. Next, the vectorizer. We create a text vectorization layer, int output, capped vocabulary, fixed output length, then adapt on the training text only, so it learns its vocabulary from the data and nothing leaks from the test set. Then a quick tf.data touch, cache and prefetch the training set, so the input pipeline is in the bottleneck while the GPU works. The model itself, a clean sequential. The input is a single raw string per example. The vectorizer goes first, so the model eats raw text. Embedding turns each token ID into a 16-dimensional vector. Global average pooling 1D collapses the whole review into one vector. A dense with ReLU does a little reasoning. A dropout keeps it honest. And one final dense with a sigmoid gives the positivity score. Compile. Adam as the optimizer, binary cross entropy as the loss. the standard pairing for a yes or no output, and we track accuracy so we have a human readable score. Train with fit, 10 epochs, training set in, validation set watched on the side. We capture the history so we can plot the curves afterward. Then the verdict, evaluate on the test. Split prints the loss and accuracy on data the model never touched, that 87%. Last, the fun part, 2 sentences I typed by hand, fed straight in as raw strings. Predict returns a probability each, and we print positive or negative with the score. And here's the closer, we built a working sentiment classifier, but it reads a review as a bag of words, order thrown away. Next episode, we give the model memory so it can read in order, left to right, RNNs, LSTMs, and GRUs.